Okay, so here's a sample calculation that you might see with an electrolytic cell. Okay, chromium metal can be electrolyzed. Electroplated from an aqueous solution of potassium dichromate. So we'll give you the half reaction. Dichromate, it turns into chromium metal. Okay, how many grams of chromium metal can I electroplate if I use that much charge? So this is just going to be stoichiometry. So I'm going to start with what I'm given, 1.00 times 10 to the fourth coulombs. Okay. Well, what can we change coulombs to? Well, we know coulombs, we can change it to moles of electrons. All right, that's a conversion that I gave you with Faraday's constant. 4.8 times 10 to the fourth. Okay, that's the charge of 1 mole of electrons. Well, what can we change moles of electrons to? Well, we can change moles of electrons to moles of chromium. So we'll go ahead and change moles of electrons to moles of chromium. And for every 2 moles of chromium, I use 12 electrons. Well, it looks like an easy step from moles of chromium to grams of chromium. Okay, weighs 52. And if you do all of that out, you get 0.898 grams of chromium. Okay, so if I use 1 times 10 to the fourth coulombs worth of charge, I can plate on anything 0.898 grams of chromium. All right. Well, how long will it take to plate 1 gram of chromium if I'm using a current of 6 amps? Okay. So again, let's start with what I'm given. Okay, I'll pretend I gave 3 sig figs there. So 1 gram of chromium. This is kind of backwards from what we just did. Let's change grams of chromium to moles of chromium. Okay. And then what should we change moles of chromium to? Well, we can change it to moles of electrons. Okay, we always want to get to electrons because then we can relate that to coulombs. So again, we knew that there was 12 electrons for every 2 moles of chromium. Okay, and then 1 mole of electrons is Faraday's constant, 9.648 times 10 to the fourth coulombs. So this will give us 1.11 times 10 to the fourth coulombs worth of charge. Well, an amp is a coulomb per second. So seconds are coulombs per amps. So 1.11 times 10 to the fourth coulombs divided by 6 amps. And that will give us our seconds, which is 1.85 times 10 to the third seconds. So that tells us how long it would take me to get 1 gram of chromium to plate out on an object. If I used a voltage of 4.5 volts, like let's say I had a 4.5 volt battery, how much energy is needed to plate 1 gram of chromium? Okay, well, energy is voltage times charge. Okay, joules are volts times coulombs. So 4.5 volts times we just found the charge in the last problem. So times 10 to the fourth coulombs. So that will give me 5 times 10 to the fourth joules. Oh, and then we can go ahead and change that to kilowatt hours with our conversion. That again, no, you don't have to memorize. 3.6 times 10 to the sixth. So this comes out to be 0.014 kilowatt hours. Okay, so you'll notice that this chapter is really just all stoichiometry and learning a few relationships. That's it.